Hello viewers, welcome to the NRA YouTube channel. In this video, we are going to know few concepts of machine learning. The contents we are going to know in this video are overfitting, underfitting, regularization and hyperparameters. Before going to the concepts, just we are learning the basics to know about these concepts. What is bias? It is simply considered as the symmetric error that occurs in the ML model itself due to incorrect assumptions in ML process. In general terms, bias is how much amount of assumption a machine learning algorithm is making about the training data is called bias. It is only based on the training data. If more assumptions are occur, then we have more bias. If less assumptions are occur, then the pattern it have low bias. Let us see this picture. Here this green dot indicates accurate values. We can see the second picture which is predicting the accurate values. Then it has low bias. We have to learn the variance, how the data points are distributed from the mean. Let us see this picture. This is the mean of the data set. Then these blue color data indicates this is distributing far away from the mean. So this indicates it has high variance. This is the formula for variance calculating. X bar is called the mean of the given data, and this variance is always having the positive values. In general terms, if you are training your ML algorithm on a slightly different data set, that means testing or validating data, you will get a different output. Then how much difference is getting, that means how much variation is getting, is called variance. Let us see this picture. This has 4 chambers with low bias, high bias, low variance and high variance. This picture indicates that the red color dot gives the accurate values, and blue color indicates the precise values. Then let us see the first picture, the picture which having low bias and low variance. That means you can see this picture, these data points are having low variance. That means the distance between each data point is very less when compared to this picture. These data points are having high difference between the each data point. So this is how having high variance. By seeing these 4 pictures, we can conclude that any machine learning engineer want to make the model with the low bias and low variance. Then we are going to learn about underfitting. When a model has not learned the patterns in the training data well, and it is unable to generalize well on the new data, it is known as underfitting. That means only the model is predicting the values based on the training data, but it does not learn the patterns from the training data, so that it does not make the predictions on the testing data. That means unseen data. We are giving a new data to our model for testing to our model. Then it will not predict correct values. That means our model may not have trained well. That means we have to train our models with more data. An underfitting model has poor performance on the training data and will result in unreliable predictions. Underfitting occurs due to high bias and low variance. In this case, we are supposed to increase the complexity of the model or add more features to our feature set. Let us see this picture. This indicates training data, and this indicates testing data. Here we see that the model is not predicting well on the testing data. Let us see this concept, overfitting. Overfitting is a crucial concept in machine learning. It produces poor performance on our machine learning model. Best fit should produce best performance. We know that any best fit data will produce the best accurate results. The training data which we are given to our machine learning model, it just memorizes the training data and it does not perform well on the testing data. Let us see these concepts. Regularization. While developing machine learning model, you must have encountered a situation in which the training accuracy of a model is high, but the validation accuracy or the testing accuracy is low. In this case, which is popularly known as overfitting in the domain of machine learning, in this regularization concept, we are avoiding the overfitting problem in machine learning algorithms. This concept is mainly deals with it is removing the overfitting problem in our machine learning model. Regularization is a technique used to reduce errors by fitting the function approximately on the given training set and avoiding overfitting problem. Types of regularization. We have three types of regularization, that is lasso regularization, that means L1 regularization, rigid regularization, that is L2 regularization, and elastic net regularization, which is combination of lasso regularization and rigid regularization. Let us see what is lasso regularization. A regression model which uses the L1 regularization technique is called lasso regularization. This LASSO abbreviated with least absolute shrinkage and selection operation regression. Lasso regression adds the absolute value of the magnitude. This value will always having the positive values of the quotient as penalty term to the loss function. Loss function is nothing but the error value. Loss function error which indicates that how much amount of error is generating by our machine learning model. Lasso regression also helps us achieving feature selection by penalizing the weights to approximately equal to 0 if that feature does not serve any purpose in the model. That means we are adding a penalty term to our loss function, then we can assign any feature to equal to 0. This is the formula for loss function. Here Wi indicates the weight that we are adding penalty to our loss function. This is the formula for loss function, and this is the magnitude of the weight. Rigid regression. A regression model that uses the L2 regression technique is called rigid regression. Rigid regression adds the square magnitude of the quotient as a penalty term to the loss function. Here we can see that we are squaring the weight, then we can get the positive values. Here lambda indicates regression value. This is the cost function. Then we are going into the concept called hyperparameters. We have a machine learning algorithm. Then we have to train our model with different data sets, which is called training data set, validating data set, and testing data set. If our model predicting best accurate results, then we can say that our model trained well and tested well. If our model is training well but not predicting best values or accurate values while in testing dataset or validating dataset, then we can call that overfitting and underfitting concepts. Okay, then we are giving input on a large dataset. Then that dataset is divided into three parts. One is testing dataset, one is validating dataset, and another one is training dataset. The input which is given to our model, then our algorithm must have to learn the patterns from the dataset. Then it will produce accurate results on the testing dataset. If only it will memorizing the data which is given as a training data set, then it does not produce any accurate results. Before going to learn about hyperparameters, we have to know the basic things about the neural network. Here we are going to learn about the neural network. If you are training our model with any data, then that data is divided into small amount of nodes. The input which is given to our model is given to the node. This node contain activation function, and each node having individual inputs. So this input will be given to the activation function, then the activation function will produce the output. Then that output will be given to the another layers. This neural network contain number of layers. This starting layer is called input layer, and the ending layer is called the output layer, and these intermediate layers are called hidden layers. In this neural network, each node is connected to another layers. Hyperparameter in machine learning are configuration settings that are not learned from the data but are set prior to the training process. Example including learning rate, batch size, that means how much amount of data we are giving to the each batch. Learning rate indicates how much amount of rate does our machine learning model is learning, and number of hidden layers we have seen before. Number of approaches, that means number of iterations that every neural network is going to perform in neural network. Tuning these hyperparameters can significantly impact the model performance. That means if you are having best hyperparameters, then the model will having the best performance. Thank you.